Okay, usually when we discuss a double slit interference pattern, we assume that the slits we use are so narrow that the light passing through each slit behaves like a point source. So it's diffracted fully across the entire 180 degrees. That's why the interference pattern we get have bright fringes that have uniform intensity. All the bright fringes are just as bright because the energy is diffracted, the energy is spread out uniformly across the 180 degrees. If we have, but usually in practice, the slits in the double slit experiment are not that narrow. So what we have is this thing called the diffraction envelope. The diffraction does not occur fully across the 180 degrees. The amplitude of the wave is largest at the middle, where the angle is 0, and the amplitude of the wave will drop off as the angle increases. That's why the interference pattern that's formed by two of such slits will look like this. You will have the bright fringes, but the bright fringes at the middle will be brighter than those towards the sides. And beyond certain angles, the bright fringes could be so dim that they are not observable. This corresponds to the regions here where diffraction hardly occurs. If the slits are even wider, then the diffraction will be even narrower. And the interference pattern you get may look like this. Because the diffraction envelope is now so narrow, you only get to see a few bright fringes near the middle, and beyond a certain angle, you are not able to see any bright fringes because the wave is not diffracted to those angles. It's important to note that we are changing only the slit width. We are not changing the slit separation, which is the distance between the centers of the two slits. That's why the positions of the bright and dark fringes remain unchanged. When we make the slit narrower, what we are changing is the diffraction envelope. So when we make it narrower, the diffraction envelope is actually gentler, it tapers off more slowly, and that's why you are able to see these higher order bright fringes that you can't see when the slit is too wide. But on the other hand, when you have narrower slits and the energy is spread more uniformly, the fringes you see are actually dimmer than what you can see if the fringes are wider. So you see more fringes, more of the higher order fringes, but the fringes you see are not as bright. Okay, that's all I have to say. Ta-ta!